Welcome to the support video for MSBT 1. We are looking at the place value system in this standard, and we are relating it to how the digit in one place relates to the number or the digit on the right or the left. In fourth grade, they looked at the multiplication relationship, and so they understood that the digit in one place would be 10 times larger than the digit to the right. What we will extend their understanding with in fifth grade is that the digit in one place is also a tenth of the digit to the left. So we're opening with a kind of end in mind. This is a sample question that we would expect fifth graders to be able to answer using that understanding based on the place value system. So what we're going to do is we'll revisit this question in a little bit at the end, but we're going to try to progress you through and connect some place value concepts and show you how you can build understanding within this concept. So let's start by just looking at the place value concept. This number is 3,333 and 33 hundredths. So we're going to start by looking at the value of each of these digits. The 3 in the thousands place is valued at 3,000. The 3 in the hundreds place is valued at 300. The 3 in the tens place is valued at 30. The 3 in the ones place is valued at 3. The 3 in the tenths place is valued at 3 tenths. We'll look at another way that you can write this in a minute. And the 3 in the hundredths place is valued at 3 hundredths. It's important to note that you guys do extend to the thousandths place. I'm just looking at this number 2 hundredths for right now. But what we would want students to do is start looking at this number and see how did the value of the 3 change. 3 hundredths related to 3 tenths, well, I know that 3 tenths is 10 times larger than 3 hundredths. I know that 3 wholes is 10 times larger than 3 tenths. Know that 30 is 10 times larger than 3. 300 is 10 times larger than 30. And 3,000 is 10 times larger than 300. If it's easier for you to start with whole numbers, fourth grade started with whole numbers, so you might want to start here and then extend that understanding to place value once you've unpacked that understanding there. But the main thing here is we want them to look at the digit. The digit's the exact same, and how does the placement on the digit change in relation to multiplication? So then we connect that same concept here, and we begin to look the other direction. Rather than going from right to left, let's look from left to right. And I see that 3,000 went down to 300. It was divided by 10. Or we could think about it as multiplying it by 1/10. We took a tenth of 3,000. So that would tell me if I had 10 groups of 300, I should equal to 3,000. So the same idea here. I could multiply by a tenth, which is the same thing as dividing by 10. It's taking 300, partitioning it into 10 equal parts. That would give you 10 groups of 30. Same idea here. 3 wholes is a tenth, a part of, so 1/10 of 30. Again, I can divide by 10 wholes, or I can multiply 1/10. So the same relationship continues down as we move this direction. I'm dividing by 10 or I'm multiplying by 10. Dividing by 10 or multiplying by 10. But they're understanding that the direction we move does change the value, and it's in that unit of either times 10 or times 1/10. So then we come to expanded form, which you see in fifth grade, we move to the expanded form where we take the value of the digit and we typically extract that from that digit. And so we think about 4 being in the 10,000s place, it's 4 times 10,000. 5 times 1,000, 9 times 100, 8 times 10. All of these would give you the value of 80, 900, 5,000, 40,000. And we continue with this kind of idea. 7 times 1, it's in the ones place, it's worth 7. 3 times 3 tenths, it's worth 3 tenths. And 2 times 2 hundredths, it's worth 2 hundredths. I just showed this to show the same idea can be applied here when you get expanded form. Look what happens to what you multiply by. That unit, again, this direction, grows by 10. It's times 10. This direction it is divided by 10, or it is multiplied by 1/10 of. We're taking it and we're splitting it into 10 equal parts. So that's a way to kind of begin to lay the foundation for place value understanding and begin to show the relationship to the place value system. So now let's kind of look at this a little bit more in depth. So we're going to start here with the place value chart. One thing I kind of want to say on the precursor is that these are place value discs. They're nothing fancy. If base 10 blocks works better for you, you can surely do that. These are just colored discs, just printed out the labels. And the good part about these is that they are transferable by unit. So you can color code them by unit, and then you can stack them or draw them eventually on the place value chart. So let's just start with something simple to show the relationship, and 4th grade does this, of to 1 times 1/10. 1 times 10. So if I think about 1, and I grow this times 10, I end up with 10 ones. So when I say 1 times 10, I end up with 10 ones, which is equivalent to 1/10. So again, I grew by 10 this direction. So then if I take 10, so I start with this 10, and I multiply it by 10, I would have to have 10 groups of 10. 10 groups of 10 is equivalent to 100. So then I take my 100, and if I want to multiply it by 10, 100 times 10, I know that if I stack up all my hundreds, if I did 10 groups of 100, I equal to 1,000. So again, this just shows and actually quantifies it by value. It's an easy, concrete way to see that in order to show that equivalent value, I move the place value this direction as I multiply by 10. So let's take this concept and let's apply it to multiplying by 1/10. So we kind of connected this a little bit ago to this as being the same thing as dividing by 10. Okay, we do want them to focus on multiplying 1/10, but we want you to understand that inverse relationship. So if we have 100 and we want to multiply it by 1/10, we must take 10 equal parts to equal 100. So if I think about taking 100 and dividing it into 10 equal parts, I know that I'm going to get 10 tens. Okay, 10 tens would equal 100. The problem is I only have 1/10 of 100. I don't have 10 tenths of 100. So I end up with 10. 1/10 of 100 is 10. So this direction, if I multiply by 1/10, I equal with 10. So let's kind of keep this moving. If I have 10 wholes and I divide 10 wholes into 10 equal pieces, I should have 10 ones. Okay, but I didn't divide it by 10 equal pieces. I did divide it by 10 equal pieces, but I only have one of those 10 equal pieces. I don't have 10 tenths, I only have 1/10. So I must take away those other 9 tenths to show that 1 is a 10th of 10. So I had 10. If I multiply by 1/10, and keep in mind that that could be written as a decimal. I'm just writing as a fraction, but you could certainly connect it to the decimal place value. But 10 times 1/10 would get me 1 whole. And then if I take my 1 whole, now I'm getting into the decimal idea, and I partition that one whole, or I break apart that 1 whole into 10 equal pieces, I should have 10 tenths. But I only have 1/10 of the whole, so I only have 1/10. So I took my 1 and I multiplied it by 1/10, and I equaled with 1/10. So you can see the progression here that as I multiply by 1/10, mine got 10 times smaller. So it shows you very easily as I slide these across the relationship based on the place where they originally start. All right, just a couple more things and then we'll close out here. Let's look at this question right here. So now we've kind of explored the relationships. Now we look at something that they'll eventually get to, is how much larger is 200 than 20? So again, I can use these place value discs. Your base 10 blocks would be fine. But if I look at 200 and I want to think about how much larger is 200 than 20. So I could think about this in multiple ways. I could think about, I know that I've got to have 20 tens total. I'm sorry, I have 10 tens in this stack, 10 tens in this stack to equal 100, and those hundreds grew by 10 times more. So that's one way to look at it. So I can see that 200 is 10 times larger than 20, because I would need a group of 10. But another relationship that I could make is to something through multiplicative comparison, which they have learned this through 4th grade. So I can take 100 and I can think if I have units of 20, so if I just stack my two 10s together, these would represent 20. How many 20s do I need in order to equal 100? Well, there's 1 stack of 20, 2 stacks of 20, 3 stacks of 20, 4 stacks of 20, 5 stacks of 20, that's 100. 6 stacks of 20, 7 stacks of 20, 8 stacks of 20, 9 stacks of 20, 10 stacks of 20, that's 200. So 200 is 10 times larger than 20. I can show this with that bar model to see how many 20s can I get out of 200. And I should see that I get 10 groups of 20 out of 200. So that's another way to draw and represent this. All right, let's look at this last question. How much smaller is 3/10 than 3? So if I represent my 3 wholes, and I think about breaking apart each of these wholes into tenths, okay, this whole goes into 10 pieces, this whole goes into 10 pieces, this whole goes into 10 pieces, but I know that I don't have 30, I don't have 3 wholes here. I have a tenth of the whole. So I only have 1/10 of each of these wholes. So I'm trying to look at the relationship that exists here. So I could think about, well, this just decreased by 10, or I multiplied it by a tenth of. Let's look at this with the bar model. I represented 3 wholes, 1 whole, 2 wholes, 3 wholes, and I'm going to cut it into groups of 3/10. So what I'm going to notice here is this is 3/10, 6/10, 9/10. I'm going to have 1/10 left over. I'll do the same thing, 3/10, 3/10, 3/10. That gets me to 9/10. I've got 1/10 left over. 3/10, 6/10, 9/10, and I've got 1/10 left over. But this 1/10 plus this 1/10 plus this 1/10 are worth another group of 3/10. So if I count, how many groups of 3/10 did I get out of this? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So again, it shows me the relationship that how much smaller is 3/10 than 3 wholes. Well, what is a tenth? 3/10 is a tenth of 3 wholes. And we demonstrated that concretely and also pictorially, just showing them the relationship as they move in that place value system. So let's come revisit this question, which is your end goal. They need to be able to determine the relationship between a digit and relate it to either 10 times greater or a tenth of. So when you look to solve this problem, they will need to go through and think which one of these actually relates to the place value system. And we hope that ultimately they can determine that right and left by what they know about the way numbers move across a place value system, knowing that this final answer choice would be what would get them to that understanding.